Let xy be identical independent random variables such that the MGF of x plus y is given below. Find probability x less than equal to 0. So we know that for independent variables x and y, the MGF of their sum equals the product of their individual MGFs. Now in this case, not only are they independent, but they're also identical. Yeah, identical. So they will have the same MGF. So let's call the common MGF as K of t. So K of t is a MGF of both x and y. And the product we know of the two is equal to the MGF of the sum. So K squared t, each of them is KT, is the given instead of using m of x plus y, they are using m of t, and so m of t is given to be this expression. And now since this expression equals a square, and whenever we have variable expressions and we know that they are equal to a square, then it means that this expression can be written as a whole square. So the way we figure out what the base of that whole square is, we look at the two extreme terms, which are complete squares. So this is the square of 0.3 e to the negative t. And then this second extreme term is the square of 0.3 e to the t. And then there's a missing middle term. Now, in this particular situation, since we know that the base is going to be the MGF of the x and the y, so, and x and y are discrete because of the way the MGF is written. See, when you have MGF as a sum of terms like this, then we're dealing with discrete variables. So the coefficients of the exponential powers have to add to 1. So right now we have the coefficients of e to the negative t and e to the t. They add to 0.6. And then the missing term is a constant term. And since this one, and this one have to add to 1, so the missing term has to be 0.4. And therefore, we know that k squared t is 0.3 e negative t plus 0.4 plus 0.3 et whole square, and therefore k of t is just this base. And that is the MGF of both x and y. But we also know that MGF is equal to the expectation of e power tx, which for a discrete variable will be the summation of e power tx times the probability function. And if you compare 1 and 2, you can spot that this sum has to be a 3-term sum. And we have powers of etx. Okay, the powers are e to the tx, and the summation is going over x. So x is being replaced by some numbers. And now when you look at 1, you figure out that those numbers for the x have to be -1 to give you the e to the negative t, 0 to give you e power 0 here, and 1 to give you e power 1t here. So the x values are -1, 0, and 1. And then the corresponding probabilities are the coefficients here. That's why I was mentioning earlier that these coefficients need to add to 1, because they are just the probabilities of the probability space. So 0.3 is corresponding to -1. So f of -1 has to be 0.3. Similarly, f of 0 has to be 0.4, and f of 1 has to be 0.3. And we did all this work to find these probabilities because, if you remember, the question was to find this probability. The question was to find probability x is less than equal to 0. Let's slowly scroll up. See, you have to find probability x less than equal to 0. Okay. Uh, so that's f of -1 plus f of 0. So basically you look at, since you're looking at x less than equal to 0, so you look at all the x values over here in the space which are negative or 0. So this is negative and this is 0. So you look at the probabilities of these two, you add them up, 0.3 plus 0.4 is 0.7, and that is choice E.